Hi there. My name is Brian Cobalt. I've been programming computers since I was 18 years old for more than 40 years. In fact, I recently just retired from a career in applications development. And now I want to get back and share my knowledge of computer programming with others. In this particular video, I'm focusing on Unity, and the programming in Unity is in a language called C Sharp. And what I want to talk about here is kind of a fun experiment that I've done from time to time over the 40 years I've been programming. It's just kind of a fun thing to do. And I'll just run this program to show what it is. I'll just run this in editor mode so you can see the results here in the game pane. So it just starts up and then it comes the prompt to say press N to display a new pattern, press escape to exit program, and press space to continue. So I'll press space to start. And all this does is it draws lines starting from all the lines start from the center of the screen and it just traverses all the way around the screen. So it starts like drawing a line from here to the bottom right hand corner, and then it'll draw lines moving up the screen, and then draw lines moving across, and draw lines down, draw lines across. So you have lines going all around the total circumference of the screen. And when I first did this on an Apple II back in the early 1980s, my thinking was, well, this would be cool because you would get this kind of 3D effect of all these lines shooting out from the center of the screen. And for the most part, that is what you get. But you notice if you look over off to the right here and up towards the top and the left, you see these little patterns show up that aren't just individual lines. And I believe those are called Moire patterns. And Moire patterns are patterns created by lines of interference. Moire is French. I believe Moire is a French word. And according to Wikipedia, that's how you pronounce it. Now, I'm not an expert in Moire patterns, so I can't say definitively that that's what these are, but that's what my thinking is. That's what that is. So I did this first on an Apple II back in the early 1980s. I did it again, maybe 10 or 15 years ago in Visual Basic using DirectX commands. So now I decided, well, I haven't tried that in Unity yet, so I wrote a program to do it in Unity. And consistently, I pretty much get the same thing anytime I do it. I mean, from the 80s all the way to now. The only difference is on the Apple II, resolution was much lower. I think even in high res on the Apple II, resolution was like 280 by 192, and this here is 1920 by 1080. So we've come a long ways in resolution since the 1980s. uh, yeah. So what I want to do here is just walk through this program and how I developed it, and then I'll talk about ways that you can change the effects of the patterns and show you how you can try different things, different patterns, so you can experiment of yourself if you want to. So let me exit the program first. So I'll just hit escape. You'll see quit down here at the bottom because I have a line to do that in the debug log just to make sure that routine that the program actually executes, because it doesn't actually do anything in the editor. The only time it does anything is when you're in a standalone built application, then it will actually truly exit the program. All right. So let me start in the editor here, and I'll start with the main camera. So I have the transform here set to 960 by 540 by minus 200, and I'll talk about that a little bit later, why that's set that way. There's some interesting things about the camera while making this application. And then I have this clear flag set to solid color rather than skybox, just to get rid of the skybox and have a solid color. And I use black for a background because I just want a black background so everything will show up really well against that. And that's basically all I really did with the camera. Everything else is pretty much default settings. And then I get to the canvas. Canvas again, I set render mode to screen space, overlay, and then I set the scale mode to scale with screen size and set that to 1920 by 1080, which matches my screen size in the game pane, which is also 1920 by 1080, so it's apples and apples. That's all that is. And then under canvas, I created a game object called LR template, and I changed nothing here. These are all just default settings. The only purpose of this game object is to serve as a template for instantiating other game objects, which you'll see when we get to the script for this program. This is also where I attach the script, Draw Manager, and it has two properties: the the LR template, which I just populated with the LR template game object, and then instructions, which I populated with the next object here with instructions. All that is a Text Mesh Pro object that just has the instructions: press in to display a new pattern, press escape to exit program, press space to continue. So, and then this event system, which just appears by default when you create a project. It didn't do anything with that. It just left that alone. All right. So yeah, just kind of go over the way with that UI works. I mean, it's pretty simple. You just spacebar to create your first graphic. Be nice if I actually ran it again. There we go. Spacebar to create the first graphic, and you press in. It just goes through and redraws it with different colors. Okay, until you hit escape to exit. So now I'll show the script that controls all that, and that's the Draw Manager script. So this starts with the variable up here called first, and all that's used is to differentiate when the game first starts and you have the instructions versus when you're actually drawing patterns. Because when you draw the pattern for the first time, you're not clearing objects, and once you draw your first pattern, for every pattern you draw after that, I want to clear objects to free up memory, so it doesn't keep using more and more memory every time you create all these objects. Then I have the game object LR is defined as an array of 6,000 objects. And then I also have a game object called LR template, hold that LR template object. And then the temp text object, which holds the instructions object. That's all the variables I have for this. Is pretty simple. Then below in the update routine, I have a really simple user interface that just checks for, did you press space? And if first is equal to first, then it's going to set first to equal to NA, because that's just a one-time setting when you first start. And then instructions enable is going to be equal to false, because I don't want to display the instructions anymore. Now we're moving on to displaying a pattern. Then I display the very first pattern. The next one just checks for you pressed an N, and first is not equal to first now, so we're no longer displaying instructions, we're actually drawing patterns. So then it will clear the objects from the last pattern that was drawn, and then it will draw the pattern again. And then the last one is looking for pressing escape key, and then it just goes to the exit program function that just, all this is down your exit program is just one line. Is, well, I guess first of all, it actually, if we've been drawing patterns and it clears objects one final time, then it just hits application quit, and that will quit the application when you're in a standalone build application. All right. The main part of this is the draw pattern routine. That's what actually draws the pattern. So this is what this does is for all these 6,000 objects that I have defined up here in this array, it's going to instantiate an object based on the LR template. That's what this line does here, right here. And then this line here is just going to make the object active so it appears. And then this line here is going to add a line renderer component to the game object. And then this next line here, it assigns a material to that line renderer, because you have to have a material assigned to the line renderer for it to display anything. This line below this that I have commented out is to set roll space for the line renderer, whether true or false. The reason that's commented out is because I found it makes no difference whether it's set to true or false. So that's something I was just experimenting with when I was setting this up. Then the next line sets the width of the lines of each line in the line renderer. And then the next line sets a random color. And then it actually sets a random number between 0 and 7 for the random color. And then it goes through a little switch case statement here. Based on what number is generated, it sets the color to the line renderer, excuse me. And that's just by setting the start color and the end color. And the start color and end color of a line renderer is to set up a gradient. So if these were two different colors, it would create a gradient going from one color to the next color. If you set both of them to the same color, then it's just a solid color line. So that's what all that switch case statement section does. It just sets the color. These four loops here, they're not actually loops, they're if statements. These four if statements, depending on whether we're between elements or game objects in the array of elements, either 0 through 1079, it'll draw one quadrant of the screen, and if it's between 1079 and 2999, it'll draw another quadrant of the screen, and if it's 299 to 4079, it'll draw a third quadrant of the screen, and if it's between 4079 and 5999, or up to 6,000 objects, then it will draw the last quadrant of the screen. Yeah, so it looks like the way this is going is I believe it's starting from right center, and actually it's going from bottom lower center, and it's drawing from the right bottom right hand corner up to the top right hand corner. Then it's drawing from the top right hand corner over to the left right hand corner. Then it's drawing from the left right hand corner down to the bottom left hand corner. Then it's drawing from the bottom left hand corner over to the bottom right hand corner. So that's the sequence it goes through. And then clear objects. All this does, it just goes through all 6,000 game objects in the LR array, and it just destroys the object. Well, first actually it sets all the removes all the endpoints from the line renderer, and then it destroys the object. So basically, it's just freeing up memory for the next pattern drawing, and that's the whole routine. It's pretty simple. But the interesting thing about this that I'm going to go over here is what affects the different patterns. So some of it is the varying the colors, the random color for each line, and some of it is the width of the line, and the other is the arrangement of lines. Now, in my example, I'm drawing lines all the way around the circumference of the screen. Another way you can create Moire patterns is by overlapping sine waves. And I know there are tutorials out there that show you how to draw a sine wave in Unity. So you can do that if you'd like to experiment with these patterns. One of the interesting things, though, is until I started with Unity in C Sharp, I did not have a way to control the width of the line. There was no command for that on the Apple computer way back in the 1980s. And the other language I tried in is Visual Basic, excuse me, using DirectX commands. And that also didn't have a way to control the width of the line. So that gave me a new thing to play with. And then this is kind of interesting because if I were to take this and make this line very, very thin, like instead of using 0.45, let's say 0.5, and make this 0.5. And then we'll save here. Okay, then I'll just go back. Let's just compile. Then run. Oh, I think I had it running. Okay, so let's go ahead and do this, space. So you see here, you get something much different now. Now you can actually see little diamonds show up, and there's places where you can see little circles. So that's definitely a much different type of pattern drawing. So controlling the width, changing the width of the line really does have a pretty dramatic effect on the patterns that are created. So that's something else that you can play with. So yeah, there's a lot of ways you can play around with this to create different patterns. Just different colors, the different line widths, different patterns with the lines. It's kind of a fun thing to kind of play with in free time and just see ways that you can create different effects. So what I will do here is I will take all the code for the Draw Manager script and I will put it in the comments for this video so you can create a Unity project and just copy paste the code in and set up your own project in probably about 5 minutes and do your own experimentation. So the other thing I wanted to do here is kind of go over things I learned while creating this project. And I've got some notes here I'm kind of following just to make sure I don't miss something I want to point out. Um, One thing you might ask right off the bat here is when you go to Draw Manager is you might be saying, hey Bri, why create 6,000 objects and then assign a line renderer to each of those objects? Why not just create one object, assign one line renderer to that object, and then set points for all 6,000 lines in that one line renderer? Well, the problem is you can only set one color per line renderer. So it doesn't matter how many lines you define in that line renderer, it's all going to have the same color. So if you want different colors for each line, the only way to really do that with line renderer is to create an object for each line and then set a color to the line renderer for that line. So I'm not doing a very good job of saying the word line renderer, but you know what I mean. Um, okay, so that's one thing to point out. And then another thing I found that was kind of interesting is setting up the camera. So let me go back to Unity. And when I talked about the camera, I said I would talk about these settings I did for the transform for X, Y, and Z. So normally when you create a project, the camera defaults to X being 0, Y being 1, and Z being -10. So if I actually were to set it at that, so I'll set this at 0, I'll set this as -1, and then actually I think that's 1, 1, and then -10. That, and then let me run this here. You notice how the camera here is now, it's no longer centered over the canvas anymore. And the reason for that is X and Y for the line, for the canvas is 960 by 440, and XY for the camera is now 0 and 1, so they don't match up anymore. That's the other problem. This image is going to be off center. And then the other issue is going to be, you'll see this with -10, it's quite a bit of difference in how it appears. So let me just run this again. All right, this, notice just like it's off centered here, it's showing up in the right hand corner rather than centered on the screen. And then all you're seeing is just a few lines. And the reason for that is the camera is so close to the canvas that you're getting an extremely close-up view of this screen. So close up that you're not even seeing most of the screen anymore. So what I have found is going 964x and 544y gets it centered on the canvas, so you got apples and apples there. And then setting this about -200 gets it far enough away from the canvas that you get to see the full screen now. And I can't tell you if -200 is the best setting or -300 or -400. I just play with it until I got something that looked right. I haven't found anything that says what a good default setting is for that. The other thing you will notice is if you watch this, when I change these settings for the transform, did not affect this Text Mesh Pro element right here. It still displayed exactly the same way. And that's the other thing about the camera is changing the transform for the camera doesn't affect built-in UI elements for Unity, but it does affect any graphics that you write or that you create, including like the line graphics that I'm creating, or it will affect like if you bring in any 2D or 3D models, it'll affect that. But it just affects graphics, not built-in UI elements, as far as I can tell. I'm not really an expert in the camera yet. That's something I still want to learn more about. But as far as I can tell, that's the scoop on that. The other thing I've noticed, and this is the thing, if anybody has any ideas on this, I'd be interested in hearing about it, is when I mentioned here I had this routine for clearing objects to free up memory, so you wouldn't keep using more and more memory as you draw patterns over and over and over again. Well, what I've found is even though I do that, it still uses additional memory each time you draw a new pattern. Not a crazy amount of additional memory, but it does keep consuming more and more memory. And I don't know if that has something to do with actually drawing the graphics itself, but it can't have anything to do with the objects because they're being destroyed between drawings. So I'm not quite sure what that's about. So if anybody has any ideas on that, I'd be curious of hearing about that. The other thing that I found out that this really threw me. After I created this program, I played around with it a lot in the editor, and then I decided to build a standalone application. And I was expecting everything to work just like it did in the editor, so I was really surprised when these instructions came up when I started the standalone application, and I hit the space bar to draw my first pattern, and then everything just locked up. So no idea, no clue, no idea what was happening. I did a lot of Googling, and I finally found the answer. And that has to do with the shader that's being set here. This is actually a shader that's being assigned to the material. This is legacy shaders, particles, alpha blend, pre-multiply. And that shader is available in the editor by default. However, it's not available in the build settings by default. So if I go to File, Build Settings, and then I go to Player Settings, and then Graphics, and you go down here, see I had to add this shader to this. There were originally only 6 shaders listed here, as they always include shaders, and this 7th one wasn't there. And because it wasn't there, it wasn't available in the standalone application, so it just crashed when it tried to access it. I found that through a lot of Googling, and afterwards I realized I could have saved myself a lot of time if I had just built the application again and selected the development build option. So what the development build option does is it includes, trying to find my, oh, here we go, X button to get out of this. It includes the, you don't see it down here, but it's where quit was being displayed when I exited. It's the console that displays error messages. So it'll include that in your build. So if anything goes wrong and there's an error, it'll throw the error so you can see what the issue is. And once I built that, included that option in there, and then tried it again without that shader in the build settings, it crashed again, but it actually displayed an error. It wasn't very meaningful, but it included a reference to the word shader, which would have given me a pretty good clue it had something to do with a shader. Probably would have come up with the answer a lot faster that way. So that's really a good little tip there. If you have an application that's just working perfectly in the editor, and then all of a sudden just bombs in a standalone application, a good place to start is just go build settings, and then on this first screen, just check that development build box so that the console will be included in the build so that you can see any messages that come up, error messages. That could be really helpful. So that's another good thing I learned. That was a really valuable tip. I didn't think about that. So that's a good thing to know. So yeah, I'd be really interested if you try this and do experimenting on your own. What kinds of patterns you come up with? Share them as screenshots, maybe possibly. It's just kind of an interesting, fun thing to do. Hope you found this video enjoyable, and I wish you all the best.